What? I mean, catch up. It's all good. Like, tomorrow we'll just make a note in our thing. No, tomorrow we'll just make a note and say that you're sick. Yeah, if you're sick, you got time to catch up. No worries about that ever. Alright. Sorry about the delay in starting class. It's middle of February, and you guys know basic student expectations, and some of your peers are struggling with that.
I'll take one more second. Has it been like more than how far are we?
I don't know. We're past day 100. So, I mean, we only have like 60 or 70 days left. I mean, if that, I don't even know. We have spring break coming in. And then we have travel. We have some days that I don't even really count. We have travel, we have May term. When we get back to New York, that last 4 weeks of a Tuesday, so exactly what it is. It's not my job to be your calendar. You should have your plan book out. It should be in your plan book. We leave for New York on May 8th. No, I'm lying. Don't ask me a question and then doubt my answer. I was looking at my planner. I'm not going to lead you astray. All right, who wants to read, or you're going to have to keep listening to me? Perhaps you've heard an adult saying something like, "When I was your age, it cost me a dime to go to the movies." Yes, always just like that. So the rate at which prices increase over time is called inflation. So just like you inflate your pool toy, prices, as they go up and expand, it's called inflation. So it's one of the many things that mathematics can help us understand, because inflation is somewhat of a just like inherent thing with as time goes by, prices are going to go up, the dollar will be worth less, so on, whatever, technology. There's all kinds of reasons for inflation. So we will be using diagrams and computations to help calculate the ways quantities like cost or height are changing. So as we work today, keep this in mind. Are we going up or down, like increasing, decreasing? What is it changing from, like what was the original, and by how much did it actually change? Alright, we're going to help Joe. So, look at the letter at the right. Dear valued customer, after several years of business, MoCare is increasing its price for lawn services. Since the cost of gas and other supplies has increased, we need to raise our prices. Our prices will increase from $12.50 per hour to $15 per hour. We hope you continue to be happy with the quality of our work. So, this is actually something that I've had to, I've experienced firsthand. When I was in college, also that's the difference between college and then having a degree. When I was in college, I tutored two sisters at the same time for $30 for an hour. Full disclosure, I'm just straight up honest with you guys. Now I tutor high school students for $40 an hour for one person. So, honest to God, I could probably make more money tutoring than I could teaching, but I enjoy working with you guys. But parents made me increase my price. Literally, the people that pay me told me I wasn't charging enough due to inflation. They're like, you need to increase your price if you're going to make people mad. So I was only charging $30. So they made me up it. Inflation just happens, right? Prices go up over time. Because the parents, well, first off, I've had 3 of their kids, but they're like, you're worth more than this, so charge more. So, Joe wants to determine the scale factor, right? How much has this increased by? So, when we look at 12.50 times x equals 15, what do we automatically know about x? 12.5 times something is going to get us to 15. What's so funny? If we have to elephant in the room and talk about my pit sweating, we can, oh, it's dried up some. Yeah. What? Were you guys okay back there? What's going on? Because we've had multiple conversations about your math journal and things in class, and I need you with me. Well, it's not if you're face down laughing. So are we good? Okay. Check this out. Work with your partner. I'll skip my question for a moment. Figure out what that scale factor is. What is x? If you need to use a diagram, there's that, but I would caution you with using that diagram right now? What is x there? We're trying to figure out that scale factor. What did we multiply by? Now I'm going to break my own rule. Yes, money needs 2 decimal places if it has any. However, right now I'm just solving the algebra. I'm not really writing anything in money form. So, Zach, if I have 12.5 and x, excuse me, multiplied, what do I do to get x by itself? Yep, because this is multiplication, and we actually do it on both sides. And I get an x value. I think you did the division backwards. So make sure you did 15 divided by 12.5. Hello?
1.2.
Now, when I asked what could we immediately know about x, that's why I asked that question, because every year when we start doing things like this, people will type their division in backwards. When I know 15 is bigger than 12 and a half, aren't you going to tell me what we immediately know about x? What do we immediately know?
It has to be over 1, but since you know that 12.5 times 2 is 25, so you know it has to be less than 2, but
Yeah.
over 1 is increasing. So you would multiply it by 0.6, but since you don't want to decrease, you do 1.6 or like 1.2 to get it a little bit higher than 2.
Yeah, I mean, that's if we're going to like guess check to get our way there. But so we know immediately x has to be more than 1, because we got bigger. That's how we know something increased. We went up, so I multiplied by over 1. If we multiply by 0.8, that would actually decrease our price. Now, what you did was 12.5 divided by 15, which tells you that the old price is 80% of the new price. But so this is where this gets really dangerous. I'm just being straight up with you guys. Like this, a lot of people kind of struggle with this word. The $12.50 used to represent what percent of their cost? All of it, right? 100%. So this used to be 100%. Based off the scale factor that we just found, what percent did we go up by? How much did we increase? Alex?
By 120%.
I agree. But if we already had the 100%, we're adding the extra 20%. So the new price is 120% of the old price. So we can make the statement, the new price, actually we could say the $15 price, is 20% more than the $12.50. Because this was our whole. This was our denominator, the $12.50. It's what we're referencing. We're referencing back to the old price. Cool?
So you know how you said you could just simplify to 20% since it increased by that?
Yeah.
So, but if you converted 20% back to a decimal, it'd be smaller.
So the 100% that we have is the initial charge that was already there. Right? So if you say the new price is 100% of the old price, it's the same. if you say the new price is 100% more than, that would actually be going up by 100%. Right? So by us saying the $15 price is 20% more, that's why we're not using the 100.
Oh.
The other way we could write this statement is the $15 price. Sorry, this has to have two words. 15 is 120% of 1250, which is not adding, it's just multiplying. Right? So this adds on top of what we already had. This just does the multiplication to what we already had.
Because if it was 120.
Yeah.
So that you saying this has to have two words remind me. Wait, is there a difference between, some people write the dollar sign with?
It's supposed to have two bars.
Yeah.
The only reason I know that is it was used some game show or whatever, and they were trying to figure out like what wasn't right, what didn't match, and there were bags, and one of them had a dollar sign with just one, and that's not technically correct. Which I think on the keyboard it actually only shows one vertical bar.
Yeah.
Yeah, just because I mean it's tiny.
So there's no currency difference. Because I was wondering if there was some weird
Research it.
difference.
All right, Paige needs our help. You know why I might like Paige?
Because she wants to rock climb.
Paige is rock climbing. So she wants to convince her grandma to let her sign up for rock climbing. Now my grandma would probably think I was going to go kill myself, accidentally of course. But when you fall, I mean, you want to be tied in, but there are climbers that don't tie in, and that's like super. Like they say they have a death wish. I don't. Like, they don't say it, but people think that. So the class normally costs $50. However, the school's offering a discount that you can only pay $34. Sorry. Paige's grandma wants to know what % of the cost of the class she would save. So, what % discount does she get? So, you and your partner work to answer part A and B. I'll give you a few minutes here. You could draw a diagram to help you. Easy question. Is this a % increase or decrease? Decrease, right? We're going down. How much money did she save? Anybody? $16.
How'd you solve that? They're not doing a %.
Yeah, I just asked how much money did she save. They just did the subtraction.
Oh, wait, we can do that all really awesome. We can do like 34%. No. Oh. Yeah, you could do 50% in what? 50% or 100%? No.
Sky, how can I calculate how much % the 16 is worth in this situation? How do we find a %? Another random reminder, guys, you are always allowed to pass. I use cards to make sure I'm talking with everybody, but you're always allowed to pass. percent something over something. Something about it. Remember? I think. I'm having a hard time hearing you because my fan up here. Percent is always part divided by whole. Then we move the decimal to get to the actual percent form. But Alex, here, what's my part, what's my whole?
Your part is 16 and your whole is 50.
Now, if you did 34 over 50, that's okay. Hang on. So, 16 over 50, I can get this over 100 if I just double. And we find 32%.
Okay. I'm officially.
Questions on how we got the 32%?
No, but you can.
So, part of a whole always, please make sure you have this model down in your notes. Please make sure you got this in your notes.
Oh, if you did 32 over 50, would it
So,
you could do that off of
isn't it 34? 34 over 50.
I mean that.
So, I'm going to change colors. If I wanted to figure out this percentage, and we did 34, the amount she's paying, bless you, over the original. The amount she's paying then comes out to be 68. So she pays 68% of the original cost. Because this is less than 100, you know you're getting a deal, right? You're paying less than the whole price. This is 68%. But her grandma asked, how much am I saving? What percent am I saving?
Oh,
32%. Moving
I
on to the next problem.
just have 10
I probably did. No, it's percentage. Sorry.
So I get that you have written down what I have written down. That's not the question. The question is, what was your computer? Six?
Yeah, no, it's no, I know.
Well, it's not fine. You have wrong facts. So the more I understand, the better.
Oh, no, sorry, not you. You draw a diagram, or you draw a
Okay, so
diagram?
why would you search for it?
Okay, we'll draw the diagram and
So
determine if it's
I bet you got like why I'm now concerned is using your mathematical knowledge and knowing how big all of our chapters are. I think most of them probably have 66 problems. Normally, I don't really care about how much you know in class, but I kind of do it wrong. But frankly, I'll check as much as I should.
Oh, we're going.
then we can times this by 10.
No, what do we do? 3 over.
We can times this by 10.
3 over.
I'm just gonna do this. Honestly,
May, if we're going to go from $30 to $33, is that percent increase or decrease?
it's percent increase.
Percent increase, right? So my original was 30, I'm going up to 33. So, Ian, how much do I increase by?
10%. No, wait, 10. Oh, $3.
Yeah, just $3, right? We go up by $3.
I was overthinking.
So if I'm going to draw this as a model, if my original was, well, I guess it should go on top. My original was my 100%, and I'm going to come back to you for the next question because you also know the next one. This is my 100%. I only increased by 3, which is not very far. So this section right in here is 3 compared to, this is what people screw up. What's your denominator here in figuring out the percent increase? We increased 3 from, and you know this, Ian. 3 from 30, right? So we went up by 3 compared to 30. That's a 10th, which is 10%. So, hold up. 2 ways to say this. We increased by 10%. Or, give me your eyes, because this is a weird way that people got to get used to. Our new value is 110% of the original. Right? So if we compare it to the original, we say it's that much up, or you can say how much more or how much less. Now we flip this around. Mina, if we go from 33 to 30, we're going down, so percent decrease. So does it decrease by 10%? Hey, you notice how I'm talking to Mina? She's only staring at me, yet you're talking. You say with a question mark on. So, from 33, sorry, I guess I should have circled the from. That means that 33 is now, and it might help a lot of you, like honestly, to draw this, because this is the weird one where people start to screw up. That's my 100%. My new value. Ian, what's my change? Stop.
$3.
Yes.
I'm sorry.
See, that's not. Wait, no. What are you trying to tell? Oh, I see it.
My change is still $3. But what I'm referencing is different. Because now my percent change when I look at it is going to be my change of 3. This is why you need this work written out, because it is confusing. I think I just said it. What's my reference point? What was my whole, my original? 33. Which can turn into 9/99ths.
What?
I believe. So really, it's like
It's about.
move your decimal 2 places, right, to convert to percent form. Just 9%. Or 9.09%. Or 9.09 repeating percent. Or if you want to round 9.9. Remember, we always have to move the decimal 2 places, that times 100, that we often don't write because it happens after.
How did you what?
What?
How did you get
What? So, I'm glad you're upset.
that? See how cool he is? He's happy we're not.
Write this down, but spell it correctly.
Yeah, but it's
Shh.
I didn't spell it correctly.
Really?
Yeah.
How am I R's? I was looking at pens. doing. Doesn't matter increase or decrease. If all you're doing is calculating the amount of change, the percent change, it's just how much did you change by over where you started. Right? Part compared to whole is now too general that we can't really keep thinking part and whole. And you can, because the part is the part that we changed by, that chunk that we added on or took off. But the whole is not what we're left with. The whole is where we started, what we reference back to. So when I talk about like change in height, let's say we track Will's height for 6 months. We're going to say his percent change would be that height gained compared to where he started. Still, height change over where he, doesn't matter. Right? And actually, they track this with old people. Your skeleton kind of starts to compress on itself because gravity and everything else. And you will, at some point, probably start to shrink in your lung. Probably start to get shorter. Yeah.
So for A, for A you'd go 30 over.
So because A was starting at 30, that's why that was our denominator then. But B started at 33 and went down to 30. Let's do a couple more. It'll make more sense as we do more.
Wait, I have a problem. I have a lot of problems.
You can't just, like, survive one more problem and then deal with your problems.
No, because my problem was on the last problem.
I know. I just want you to hang on and try
No,
it.
I have a problem with the graph.
Okay.
It's that.
Which one? The one up here or the one down there?
The one down there, actually. So, would 30 be 90?
No.
What?
Because this, hey, I feel like a lot of us probably aren't thinking as critically as Annie, and you're just like letting it go, and she's really trying to analyze. She's asking, so wait, what percent then exists here? Because if this was 100, stop. I mean, would you like to come teach it? Do you have a degree in mathematics? I love you guys. Truly, I do. You guys are awesome. You have to listen to me. This is not 10%. It was up there. But this is a different situation. This is a different reference point. Because we went from 33, that's our 100%, right? That's the whole thing. So when I say how much is this loss amount, we're calculating the part that we lost was 3 compared to an original value of 33, which, as angry as this makes you, comes out to be that repeating decimal. Let's round, make our life nice, and we'll just say, okay, fine, it's 9%, or if you really want to, 9.1%. So that chunk is 9.1%.
So then, would 30 be like 91.9-ish?
90.9. Sorry that you can't really read that well.
Why is it off
Because it's
The 30 is 90, sorry, not, yeah, the 30 is 90.9% of the 33. Or we could say the $3 loss is 9.1% of the 33. But it's the of the 33. We're referencing the 33. That's our total. It's not very nice to work with. Hang on for a couple more problems. As you start to see physical like examples where we reference an original height compared to a new, it'll make more sense, I promise. So, I have, honest to God, had to walk out of a store from being so frustrated at people not understanding basic math. And I don't always have the effort to teach them. A lot of times I'll be like, hey, you should. Like, my math counts people saw me go tell the guy to stop recording because I'm a rule follower. He was going to ruin stuff for everybody. You can't record the end. I follow rules. I don't want to get in trouble. I don't want people to. Ask Mrs. Bordering about us at the play last night. It was pretty funny. But, no calculations, right? You're not allowed to put it down. Put it down, put it down.
Oh, yeah, put it down.
Yeah, Will.
He was holding it. Sorry.
So,
Yeah.
the shoes originally cost $46. If his coupon is going to get him 10% off, now this is a really simple question. We're going to tear it up. Will he pay more or less? He'll pay less, right? So is this percent increase or decrease? Decrease. What's our percent decrease in this situation? Percent decrease. 10%. 10% of what? 46. So when we calculate this, 10% we know is a tenth. So a tenth of that is 4.6, right? Sweet. So we could do the subtraction and figure out the price. However,
No, 46 minus 4.6.
No, you're wrong.
Oh wait, no.
1 point.
Jordan.
Get out of here. Oh.
That was great.
Because you don't have
however, stores are scam artists. I've worked at Sears, I've worked at Old Navy's, I've worked at Macy's, I've worked all over the place. Stores are scam artists. So before they release the coupon, right? Nobody knows that we're going to have a sale. What?
They raise the price.
They raise the prices. Track your algebra tiles, guys. So the store, knowing they're going to release this coupon for 10% off, says, guys, we got to get in front of this. Raise the prices by 10%. We got the coupon coming. 10%. We're going to. So that 10% now, we actually decide to increase the price point. This math is easier. So what do they now tag the shoes with? What is the price increase? $50.60. Right? They're a scam. They know this coupon's coming out. They increase the price first.
Yeah, they're
Not
not
really.
Becomes the original price.
So that, say it again, Zen.
So it becomes the original price once the 10% is taken off, and it just makes them sell more because they're like, oh, 10% off, I should go buy this. But no one really knows that price is the same.
That is amazing.
Now,
They are really
here,
smart.
Unless you're smart, like Mr. Watson, unless you get huge a lot on there. Then you can tell. Don't know.
I've never been fired. I get bored. It's like people, when I tell them I've had that many jobs, like, you must get fired a lot. Never been fired. I get bored and I find a better paying job.
So you're like, hey,
So,
I'm gonna go
I never get bored here, trust me.
Wow, that was harsh, Naya.
On the pay thing, one, Worthington actually pays pretty well compared to like districts in Ohio. Two, I don't get bored here. So,
You never get bored.
now, Akari has no idea this has happened, right? He walks into the store and he's like, I got a coupon, and the shoes are $50.60. Figure out what Akari's price is when he goes to checkout and he saves 10%.
Because 10% decrease and 10% increase.
Would you just do the math?
Oh,
Because it's going to blow your mind. I'm going to have to clean up brains later, but you're wrong.
That's not $5. Oh, it's 4.6.
Guys, can you? Oh.
It's $4.50.
I figured it out. They're losing more money then. Is it right? No. Wait,
Well, what do you
we
do?
gotta check.
Oliver, take us to school.
So, she's not taking the 10% of the 46. It's the 10% of the $50.60. It is 10% off of $50.60. So when you use
Off
the
of.
Okay.
so when you use the 10% off coupon, you're actually paying less than the
Because
original
10%
price.
of that is.
Because it's more than 10% of $46.
Because the increase
I mean,
was
it's not much
referencing the old price, and the decrease is referencing the new price, Akari's actually going to pay
45.
Oh, yeah.
Oh,
so. And
How much would the store have to increase their price to have it even, like to have it equal 46?
you're asking a really loaded question. So, Annie, yeah, no, that's a great, but you're going down a really dangerous path.
Oh.
It's like a lot of math path. I love it, but for like 7th graders to ask this, I'm just kind of like being caution. Here's a warning sign, danger ahead. Annie just asked, what percent would the store need to increase it by in order for it to be like 46, right? Their price to end up being the same. However, so let's say the store decides to increase the price by 12%, but now I can't still take away 506, right? Because now my whole amount would change.
I don't know.
So, and now don't write this down. Do not, right? I don't often say this. What percent does Akari end up paying? Percent, Alex?
He ends up paying 90%.
He pays 90%, right? 90% of the new price for the shoes, right? Now, the new price for the shoes is the original price, right? 46.
No.
I'm showing Annie how dangerous this gets. That 46 times whatever percent they increase will be 100, like something, so the percent increase, 10%, this would have been, but that didn't work, right? So this would have to be like, if we go up by 11%, this now becomes 1.11, or up by 12%, 1.12. So if we went up by 12%, something like that, but then what we're saying is that Annie wants this all to come out to still be equal to 46. So this we're not sure of. We could solve this, but that would be some unknown while we approach this problem.
I mean, if you want 46 times
Don't write this down. I just want to blow your mind with how beautiful this is. 0.9 times 46.
Oh no, it's gonna be some like really.
You said no.
I did not say no calculators. That was when we were only working with the 10%.
Oh.
So, they would need to now this isn't even what the book was asking us, because we're going deeper than that.
We're better than we are. God.
What do they need to increase by? Hold on.
Oh, 1 point.
What do they need to increase by to actually make more money from this? So that their sale actually makes them more. What is this percent increase? That's your original rate. That's your 100%. This is 11.1 repeating. So if they just did 11.2% would make, or 12% would make them money. 13 would make them. But if you want them to be the same, if you want the shoes to end up, and this is why we get messy repeating decimals and stuff, because that's not nice math. But that's all right. If we increase by 11.1 repeating percent, they'll be equal. Anything more, they'll make money. Anything less, and they lose a little bit of money. But I mean, they're making. I mean, the shoes probably cost them like $20.
Yeah.
We went way deeper on that than we were supposed to, but that is totally fine.
You're welcome.
I don't really know how to label A, B, and C and stuff on that. But your homework's 85. Please get that done. We're gonna do a homework check tomorrow.
What?
Yeah, but it won't check 7 on 7. So homework check will only go through last week's. So last week's homework. You've been absent. You're fine. It's not for you. Don't
Yes,
worry.
but me, I still have to bring out grass and stuff.
Okay, get on it. Have a great day, guys.
You too.
Thank you very much.